applications of rational equations. And so we're going to write story problems, and we're going to be using fractions, rational equations. And the first one starts out pretty basic. It just says, in the United States, 1 out of 50 homes is heated by wood. At this rate, how many homes in a community of 36,000 homes are heated by wood? And so we're just going to assume, because it says at this rate, that it's proportional. So if 1 out of 50 homes is heated, and we're assuming that the rate is the same, we want to know how many, that's our variable, out of 36,000 are heated. And so, by wood. And so that's your formula. And I would probably just recommend cross multiplying, since you only have one term on both sides. So I have 1 times 36,000, which is 36,050 times x. And then to get x alone, we'll divide by 50. So you can punch that in your calculator, and 36,000 divided by 50 is 720. And it's a story problem, so we have to label it. So 720 what? Well, we were just finding out how many homes out of 36,000 are heated by wood. So we know the answer is homes. 720 homes are heated by wood. Alright, now this second problem, I would star this one, because this one's your next exam. And this is a work rate problem. And it says that Greg can paint a room alone in 3 hours. His brother Rob can do the same job alone in 5 hours. So how long would it take for them to do it together? And I like to ask the class this when I have you in front of me, and a lot of people will pick a time in between 3 and 5. But think about that for a second. That really doesn't make sense. If Greg can do it alone in 3 hours, it's going to be faster. So let's think about this. If Greg were alone, how much of the room would be done in 1 hour? And we know if it takes him 3 hours to do it all, he would have 5 hours. So what portion would he have done? And he would have 1/5 of it done in 1 hour. So if we add those up, we're going to get the portion that they would have done working together in 1 hour. Okay? So he would have 1/3 of it done, he would have 1/5 of it done, but if we're working together, we want to know what fraction they will have done. So now we have a rational equation, just like we solved in the last section, and we have an equal sign, which we love because that means we can cancel the denominators. So all I have to do is pick the least common denominator, and it is 15x, so I'll multiply every single term by 15 and by x. And if you don't have multicolor, maybe stick that in a box so you remember that you're doing it to the problem. Whatever works for you. I'll write that right there. And this one we get 3, and this one the x's cancel. So I have 5 times the x still there, plus 3 times this x equals 15. So combining those x's, we get 8x, and then dividing both sides by 8, we get 15/8. So again, it's a story problem, so we have to label it. So 1 7/8 what? What did we just find out? Well, what was the question? How long would it take for them to do it together? 1 7/8, what unit are we in? Hours. So we know that if that were on the bottom, that's the fraction they would have done in 1 hour, but 1 7/8 is the actual time, just like 5 was his time and 3 was his time. Alright, last one. A fisherman traveling on the Pearl River takes 2/3 time as long to travel 6 in his boat than to return. If the boat speed is 25 miles per hour in still water, find the speed of the current. So what I like to do is try to summarize this in as simple as terms as I can. And what I basically find that it's saying is that it takes him 2/3 as long to go downstream, and he's going to go 60 miles. So the downstream time is 2/3 of the upstream time. That's how I would summarize what they're saying. And then here's another thing we're going to think about. If we know the equation distance equals rate times time. We're supposed to be familiar with that. We can see it a lot in math. See per something, that's a rate. And you're given a distance, 60 miles. But we don't know anything about the time. So what I'm going to do is I'm going to come over here and solve for t just by dividing both sides by r. What's useful is that, look, I have downstream time, so I have a time. And what do we say a time is? A time is a distance over a rate. So I've got a distance over a rate, my downstream time, because that's what time equals, right? It equals a distance over a rate. And they don't give us any hours here. They just give us distances and rates. And then we know it is. We know that in math, is means equals. 2/3 doesn't change in math, so I still have 2/3. Of. What is of in math? Of means multiply. You better know that. That's important. Of the upstream time. Now the upstream time, again, will be a distance over a rate, won't it? We know the time is upstream here. So, what is my distance? How far am I going? Well, in both cases, whether I'm going downstream or upstream, I'm going 60 miles. So I can go ahead and put that in for the distance. And I can do that in both of those fractions because both distances is 60. It does not change. Now, this is the downstream. The boat speed is 25 miles per hour in still water. So if the water wasn't moving, I'd be going 25 miles per hour. But if the water is moving, I'm going to be going 25 miles per hour plus the rate of the water. And we could call that R for rate. I'm going to call it W for water. You can call it whatever you want. You can call it X. But I'm just calling it W because I know that's the rate of the water. And then for this one, we want the upstream time, right? And we know that time is distance over rate. So I have a distance of 60, and my rate going upstream is going to be the 25 miles per hour that the boat's going. Subtract the rate of the water now. Have an equal sign, so we know that we can count here. Notice that this times isn't an add or subtract, so this is all one term. So maybe I'll take this step. Since I'm running out of room, I'll go beside me. I'll take this step and just simplify that so that it's I'm just going to combine this. And you know what? I'm going to combine it by reducing, because I know 3 goes into 3, 1, and 3 goes into 60, 20. So I have 2 times 20, so I have 40 on top, and I have 25 minus W on the bottom. So just a little bit smaller equation to work with. Then I'm going to go ahead and multiply by the common denominator, and the common denominator is both 25 plus W and 25 minus W. And so we have to fit that in both of those, and I'm so out of room. But here the minus will cancel, won't it? And here the plus will cancel. So what I'm left with is my 60 times 25 minus W. What I'm left with here, I've got my equal sign, then I've got my 40 times 25 plus W. So multiplying 60 times 25 is 500, and 60 times W, of course, is 60W. 40 times 25 is 1,000. Wait a minute, this is 1,500. I was glancing at my notes because I didn't have that calculation in my head. 60 times 25 is 1,500. Make sure you make that right. 40 times 25 is 1,000. And distributing, I get 40W. Alright, now getting my W's on the same side, I'm going to choose to take 60 over here just so that it's positive. So I'm going to add 60 to both sides, so I have 100W. And then I'm going to subtract 1,000, so I get 500. So, I'm off the screen, aren't I? So, dividing by 100, we get W equals 5. And what did we just find? Well, W stands for water. So what I just found is the rate of the water, right? We had it right here in the rate column spot. And we know we label rates as miles per hour. So my answer is 5 miles per hour. Now, that was just they tried to pick 3 problems that really summarize the homework, and they're all good. They start out easy proportions, and when you see problems like this, they can be the time it takes to do a job. I've also seen water filling a pool, water going in this fast and going out this fast, or there's 2 spigots filling up this fast plus this fast. So when you see those problems where you're adding 2 rates together, that's what you want to pay close attention to. Those are the ones that they like to put on your tests and your finals. So good luck with 6.6, you guys.